Hello, hello, hello. యా వినిపిస్తుంది అనుకుంటున్నా. ప్రస్తుతానికి ఛానల్లో వ్యూస్ అస్సలు లేవు. ఓకే, ఈరోజు నా ఫస్ట్ స్ట్రీమ్. లెట్ స్టార్ట్. ఓకే, నేను నాకు లీడ్ కోడ్లో కొంచెం ఎక్స్పీరియన్స్ ఉంది ముందుగానే, కానీ నేను మళ్ళీ ఫ్రెష్గా స్టార్ట్ చేద్దామని అనుకుంటున్నా, రైట్ ఫ్రమ్ బేసిక్స్. సో అందుకు నేను యూట్యూబ్లో స్టార్టింగ్ ఫ్రమ్ టుడే ఐఎమ్ గోయింగ్ టు స్ట్రీమ్ ఇన్ యూట్యూబ్. సో ఫస్ట్ నేను అరే సాల్వ్ చేస్తాను. సో దీనికన్నా ముందు నేను ఏం చేశానంటే సెలక్షన్ సార్ట్, ఇన్సర్షన్ సార్ట్, బబుల్ సార్ట్, క్విక్ సార్ట్. ఒకవేళ ఆ టార్గెట్ నెంబర్ ఈ అరేలో ఉంటే మనం ఆ ఇండెక్స్ని రిటర్న్ చేయాలి. ఇన్ కేస్ ఒకవేళ టార్గెట్ అరే లేకపోతే -1 రిటర్న్ చేయాలి. ఇక్కడ చూసారా 9 అనేది ఇక్కడ ఉంది. అది ఏ ఇండెక్స్లో ఉంది? 0 1 2 3 4. ఎందుకు 4 ఆన్సర్. ఇక్కడ వచ్చేసి అరే ఇచ్చారు, టార్గెట్ వచ్చేసి 2 ఇచ్చారు. ఇక్కడ టార్గెట్ వచ్చేసి 2. ఈ అరేలో అసలు 2 ఉందా? లేదు. ఒకవేళ టార్గెట్ అనేది అరేలో లేకపోతే ఏం చేయాలి? -1 రిటర్న్ చేయాలి. సో సేమ్ ఇక్కడ కూడా అలాగే. సో ఫస్ట్లో ఏం చేస్తా అంటే నేను ఫస్ట్ అరేలో ప్రతి ఎలిమెంట్ ఇటరేట్ అవుతా. ఒకవేళ ఏదైనా ఒక ఎలిమెంట్ టార్గెట్ కి ఈక్వల్ అయింది అనుకో, నా ఇండెక్స్ ని రిటర్న్ చేస్తున్నా. అది ఫస్ట్ నాకు వచ్చిన అప్రోచ్. ఫస్ట్ ఏం చేస్తున్నా, ఇంట్ I ఈక్వల్స్ టు 0, I ప్లస్ ప్లస్, ఇఫ్ కరెంట్ నెంబర్ డబుల్ ఈక్వల్స్ టు టార్గెట్ దెన్ ఐఎమ్ రిటర్నింగ్ ది ఇండెక్స్. ఒకవేళ అసలుకు ఒక ఇన్స్టాన్స్ కూడా ఈక్వల్ కాకపోతే మనం ఈ ఫర్ లూప్ బయటికి వచ్చి -1 రిటర్న్ చేస్తాం. దట్స్ ఇట్. Yeah, it got accepted, but okay, now let us analyze the time and space complexity here. Time complexity is, okay, this loop is going to take big O of n times because we are iterating each element in the array. So it takes big O of n. And do we use, did we use any extra space here? No. So the time complexity here is, so the time complexity here is big O of n. Space complexity is, okay, we are not using any extra space, so it's big O of 1. Okay. As of now, the stream is running fine, I guess. So now let's get back to the problem. So the loop is going to take big O of n times because it is going to iterate each and every element in the array at the worst case, and we are not using any space here. So it takes big O of n time complexity and big O of 1 space complexity. Now, can we reduce the space complexity here? Okay, it is least minimum possible here, so we can't reduce it further. Now time complexity. Can we reduce the O of n to anywhere something big lesser than big O of n? Okay. We are searching, right? Okay. There are some algorithms where we can search the element in big O of log n. Okay. Okay, there are conditions in order to use big O of log n condition. For binary search, the array needs to be sorted. Okay, let's see the problem description again. In problem description, they have mentioned that the array is already sorted in ascending order. Okay, if the array is already sorted, then it makes our life easy because there is an algorithm named as binary search where we can search the element in big O of log n time. Okay, I will discuss how it happens. So for instance, let's take an example from the array -1 0 3 5 9 12. So firstly what I am going to do is I will take the middle element in this array. So the middle element is first index plus last index by 2. For now low is 0, I is 0 1 2 3 4 5, I is 5. Now middle is equals to 0 plus 5 by 2, which is equals to 2. So for now the middle element equals to 2. 0 1 2, which is 3. Middle is at 2 and element is 3. Okay, what is our target here? Target equals to 9. Okay, we are checking here. Okay, whatever the element at the middle is less than, there are three conditions here. First condition is if target is greater than middle element, and the second condition is going to be, second condition is if target is less than middle element, and the third condition going to be, the third condition is this, if target double equals to middle element. Okay, it's easy, right? As the array is sorted, okay, firstly let us discuss about the first condition. As the array is sorted, so for instance, for now the middle element is 2, so which is the middle element is 3 and the target is 9. Let's compare. Is the target is greater than, is target is greater than middle element, is target is less than middle element, is target double equals to middle element? We can see the target is greater than middle element. Okay, we can see the middle is 3, 0 1 2 3 4 5, 5 by 2 is 2, 0 1 2, yeah, middle element is 3. So for now the target is greater than the middle element. So if the target is greater than middle element, then we don't need to check the every element which is lesser than the middle element. So we ignore everything. So here we will make low is equals to mid plus 1. We are ignoring everything before mid element because those elements are less than target, which doesn't make sense searching them. So we reduce our search space to half of it. So now the search space is this. Now the index of 5 is 3 and this is 5. 5 plus 3 is equals to 4. Now the middle element is 8 4 and the element is 5. We can see here the element 5 is lesser than target. Again we come here. Okay. In case if the target is less than the middle element, what is the point of searching every element after the middle element? Because the every element after the middle is greater than the target. So it doesn't make sense searching every element from mid to end of the array because those elements are those elements are greater than the target. So we do here I equals to mid minus 1. We are reducing the search space. Okay. In case, so if the target is the middle element, then we have found the target, which means that we are returning the index, which is mid. This is exactly how binary search is going to work. See, firstly, what I am doing, I am doing binary search, right? Int low equals to at 0 and int I equals to at names dot length minus 1. Int low equals to 0, int I equals to names dot length minus 1. And we need to do this while low is less than or equals to I, because we are searching in between low and high, and I mean to find the mid equals to low plus high minus low by 2. I'm doing this thing because to avoid integer overflow. And we have three conditions, which are if target is greater than names of mid, what we are doing, target is greater than names of mid, we are doing low is equals to mid plus 1. Next, else if target is less than names of mid, what we are going to do, equals to mid minus 1. Which means we have found the target, so we are writing the mid. If we don't found, we are returning minus 1. That's it, easy. Now let's submit it. Yeah, it got accepted and beat 100% of the users. Okay, we have solved our first problem, which is binary search. Firstly, I use linear search, then I use binary search, and which is optimized one, so I'm going forward. And I don't have any doubts in here. Now let's start doing this. Then let's done this thing too. Oh, yeah, I need to make it too dark. Okay, now it is, we have given an array. We need to find the largest element in it. Okay, how can we do this? Hmm, I will sort the array and return the last element, which is maximum. Yeah, it's a really good idea. So arrays dot sort of arr and return arr of arr dot length minus 1. Yeah, which is good. Hmm, this should work because we are sorting the array and returning the last element in the array, which is largest. It's common sense. Why it's taking this much time? Yeah, sample test cases are accepted. Let's submit this. Yeah, it works fine. And let us analyze the time and space complexity here. For sorting the array, it will take big O of n log n. For sorting, it will take big O of n log n. Time complexity and space complexity is big O of n. For sorting, just for sorting the array, yeah, we need to find a solution that which takes less time complexity and less space complexity. How do we need find it? How do we find it? How can we find it? Okay, I was like, I will remember each and everything. So initially, I will start from 1. I will take as maximum as 1 and I go forward. His current number is greater than maximum. If it is, then I will replace 1 with 8 and I will keep as 8 as maximum and go forward. That's the process which I am going to do here. So for initially, I don't know which is maximum. So I'll take the first element in the array as maximum. Then I will start iterating in the array. Int I equals to 1. I is less than ARR dot length and I plus plus. What I say? If current element, if current element is greater than maximum, then I am updating to maximum to the current element. Yeah. By the end of the day, I'm just returning the maximum. That's exactly what I am going to do here. Let us analyze the time and space complexity here. It is going to run for n times and we haven't used any extra space. So the time and space complexity here is the time complexity takes big O of n and space complexity of big O of n, which is constant and which is perfectly fine. And this is the final efficient, neat and efficient code. So let's submit this. Yes, it got accepted and it is an efficient and optimal approach. Okay, I also have an idea. We will use ChatGPT here to analyze our codes. Mm, just I will say I will give the code and review it. I will give the code and review it. Um, let's see what does it give. Man, why charge is taking much time? Okay, reply mostly correct and efficient, but the comment about time complexity is incorrect. Okay, it is for linear search, right? So it's mostly right because I haven't mentioned the time complexity for optimal approach. Yeah, it's good. Final version. Yeah, my code is right and it is really optimal. Now let's view here. So for this, the time complexity is big of n. Space complexity is big of 1. So let's view this. This it's a well written and a clean code. Okay, the first two things are completed. Let's go to third one. Given an array of partial integers array, return the second largest element from the array. The second largest element doesn't exist, then return minus 1. It is what it was saying. Okay, I was like, I need to, okay, same here, I will sort the array and return the second last element. But when we sort the array, the elements will be in ascending order. If there are any duplicate elements, the approach will be wrong. Because, for instance, let us take an example. If it has 1, 2, 3, 4, 4, 4, 4, here the second largest element is 3. But according to what I think earlier, the output will be 4. So it will not work. Again, we need to do some extra stuff. Like if we know maximum, we need to iterate from last of the array until we found something which is less than maximum. If we found something which is less than maximum, then we return it. So in order to avoid that, we need to find something that which stores duplicate numbers but sorted. So I know a data structure, three set of integer. Okay, Okay, let us skip this. Okay, we know how to do, right? So this is how we do brute force. Okay, this is how we do brute force. Okay, let us directly jump to optimal approach. Same here also I am making something. Okay, here also I am taking a maximum variable. For now the maximum is 12. If I encounter something that which is less than, same here int max, int second max equals to -1, because we don't know the maximum second maximum here, and I am iterating every element in the array. If maximum is less than number, then I was like, do set max as max and maximum as number, because we're changing it, right? And if current number is not equals to maximum, and then sec max is less than current number, I am making sec max as current number. By the end of the day I am returning sec max. Yeah, that's what exactly I'm going to do here. Let's run this and see the output. Yo, yeah, what the hell has just exactly? Okay, I will compile this. Let's pass the custom test cases. Now let's run with all the test cases. Yep, it passed all the test cases. It is the optimal approach, which is big O of n and extra space is big O of 1. So let us to review this. Review this. This is a logic flaw. No, it is right. Maybe ChatGPT is drunk. Okay, this one also complete. Now let's start doing maximum consecutive ones. Maximum consecutive ones. Okay. ఫస్ట్‌లి మనం ఒకవేళ అరేలో ఎన్ని వన్స్ ఉన్నాయో తెలియాలంటే ఏం చేస్తాం? ఒక వేరియబుల్ తీసుకొని దానిలో ఒక వేరియబుల్ తీసుకుందాం. ఇనిషియల్లీ 0గా ఇనిషియలైజ్ చేద్దాం. Okay, first I will take an variable and initialize it as 0. Then I will iterate each and every element in the array. If the current element is 1, what I am going to do? If the current element is done, I will increment those variable. By the end of the day, I will know how many ones in the array. Okay, same here also I am doing that only. So what I am going to do is I will take an variable count which is 0. Same for int I equals to 0, I is less than names dot length and I plus plus. If array of I double equals to 1, what I am going to do? I am going to do count plus plus. By the end of the day, I am going to return the count. So this is what I said before. Okay, this is not answer. I am just running it. Let's see what will be the output. Okay, it's not array. It's names. Sorry. Yeah, it will give the number of ones in the array. For example, there are 5 ones in the array, so the output is 5. And coming to here, there are four ones, so output is 4 here. Same. Okay, for example, if we encounter any one, we'll increase the count. Okay, then okay, if we encounter anything other than one, what I am going to do is I will store the count of this int maximum equals to 0. I was like maximum is equals to math dot maximum of maximum comma count, and I will going to do count as 0. Yeah, by the end of the day I'm going to return the max. Same here also that one. Yeah, even after by the end of the year we need to add this. For example, if there is R once, we will never enter to this else statement, right? So that's the reason I am adding this max here too. Let's submit this. Yep, it got accepted. And this code is also the optimal one. Let's ask ChatGPT to review this. It's correct and optimal. Yeah. So let's go to next question. Rotate array by one. Given an array, rotate the array by one position in clockwise direction. What is clockwise direction? For example, okay, I'm going in Java. Let's select Java. For example, there are five elements which 2, 3, 4, 5. Rotate by one. Okay, and was like for now it is one like this, right? Then I need to rotate one element, exactly one element. So it will happen. I will remove 5 from start and I will add a 10 into 1, 2, 1, 5, 1, 2, 3, 5, 1, 2, 3, 4. Exactly. See, I am just removing the 5 at the last and adding 5 to that 5. We can observe something here. What happened is initially the array is 1, 2, 3, 4, 5. Now it became 5, 4, 1, 4, 2. Okay, how can we do this? Okay, I was like, okay, let's reverse this array. Now let's reverse everything after 5. 5, 1, 2, 3, 4. Yeah, that's it. That's exactly how we are going to do this. Okay, we need to reverse the array, right? So for reversing the array, I will write an separate function here. Public void reverse. What the array we are reversing and starting and ending. Okay. If flow is okay, while flow is less than I was like take in temp equals to array of flow. Array of flow is equals to array of I and array of I equals to temp. Now I'm going to do by the end of the day I'm going to do low plus plus I minus minus same here. What I'm going to do first? I'm going to reverse the entire array, right? REVRC reversing the array, entire array. So 0 comma ARR dot length minus 1, and then I'm reversing the array. We're starting from first index, length minus 1. And also need to add an extra condition here, and then low is less than. I don't think it will be needed. So let's run this. What's the error? There is no variable I anta. Okay, let's make it I. Now this should work because I have given the parameter name as n, but the inside the function I will give it as I, which is wrong. Okay, the sample test cases have worked. Let's submit this. Yep, it has passed all the test cases. Good to start this. Okay, now let's go to next problem, which is rotate array. Given an integer array, rotate the array by k steps where k is non-negative. So they are like, okay, we need to rotate the array in clockwise direction. See, if they give the k value as 3, then we need to take the k3 elements and we need to keep at this. So here also same. Whatever we do, here we are doing only one time, but here we are going to do k times. We are going to do there one, and but here we are going to do k times. See exactly. Firstly, I am going to reverse the entire array. Then I'm doing like k plus 1 to array of n minus 1, and I'm submitting it. This is exactly the answer. Just one variable change and it got accepted. Okay, the elements are ARR, right? That in GFF it is ARR and it is lens. Okay, we got error. For instance, for k is 3, so I'll need to keep k as k only because k starting it is 0 index, right? So it needs to be k. Okay, it was like again here after reversing we need to reverse the first half also here. According to the problem description, we need to do first half also. Comma. Yeah, that's it. This should work. It got accepted. Let's submit this. I think it will give error because the k value is 0 to 10 power 5. Man, the array size is 5 and the k value is 10 power 5. It is definitely going to give error. Which type of error? Array index out of bound exception. How to handle this, man? For example, if the array size is 2 and k is 3 time, because if you rotate it 2 times, it will get back to its original position. After that, okay, so that I am going to do k value as k is equals to k modulo arr dot length, which is good thing, right? Now let's submit this. Okay, I need to comment on this. Let's submit this. Oh sorry, first I need to run, right? It got submitted, which is right. Now let's do the next problem. Move zeros. Given an integer array names, move all zeros to the end of it while maintaining the relative order of the non-zero elements. So I was like, first I will keep as previous equals to 0. For int I equals to 0, I is less than names dot length I plus plus. If current number is not equals to 0, what am I doing? Then I am doing nums of previous equals to, then I'm doing nums of previous equals to nums of I, and I'm doing previous plus plus. Now from int I equals to previous, I is less than nums dot length and I plus plus nums of I equals to 0. Yeah, this should work. Yeah, it worked. Let's submit this. Yeah, it got accepted. Now let's ask ChatGPT for the review. This still zero watching, bro. Yeah, it's optimal. We don't need to do all this stuff. We just need to know whether it's optimal or not. Yep. Now let's do the next problem. As of now, we are at rotating is completed. Move zero is completed. Now remove duplicates from the sorted array. Okay. This is also same. Whatever we do before. Int previous equals to -1 and int prev index equals to 0. Okay, I need to know just the index, right? Uh, for instance, for now the previous index is 0. Now I am iterating. For int I equals to 0, I is less than nems dot length and I plus plus. So I was like, if nems of I is not equals to previous, okay, if nems of I is not equals to previous, then I was like, is not equals to nems of previous, then we are going to do, then I'm storing nems of previous plus plus equals to nems of I. Yeah, simple. Yeah, that's it, I guess. Now I need to say return previous -1. Yeah, return previous one, I guess. Because I'm starting with 0, right? Should well, bro. Output is 2. Oh man. So for instance, for now the okay, I need to do plus plus here. First we need to increment it and add, right? Yeah, I need to do previous +1. If I have started with 1, we need to do previous -1. If not, we need to do previous +1, which is correctly valid. Let's submit this. Yeah, it 100% of the users. Now let's move to next question. And also let's move in before moving to next question. Let's ask ChatGPT whether it is optimal or not. Is this optimal? It's optimal. So there's no problem for now. Missing number. Now let's start doing missing number. Okay, how can we do this? Okay, we have given an array names containing n distinct in the range of 0 to n. Return the only number in the range that is missing. So I was like, I will add every element between 0 to n. I will take as formula int n equals to n into n minus 1 by 2. Okay, I add return. Now I need to know this sum. Int sum equals to 0. For every integer name means sum plus equals to number return n minus sum. This should work. So what is number n here? Uh, Okay, let us take as k here. In n equals to nems dot length. Yeah, it should work now, and it is going to be k. Everything is wrong here. It's n minus 1 or n plus 1. It's n plus 1. Damn, bro, why are you laughing, bro? You have failed even the 10th class basic problems. Should work now, and okay, sum of the first n characters is n to n plus 1 by 2. Don't do n minus 1. You will get straight away rejected from the interview as you don't know the basics. So remember this. Now let's start GPT this. Correct and optimal, so no need to check the report. Now we need to find all the unions. Let's array given to sorted arrays. Okay, we have given us sorted links. So what I was doing here is taking a list integer list equals to new array list. List of integer list equals to new array list. I will take int I equals to 0, int j equals to 0, while I is less than a dot length, and then b is and j is less than b dot length. What I'm going to do is if list dot size double equals to 0, that was like I'm searching first. If a of I is less than b of I, if list dot size double equals to 0, then we add list dot add of b of I and b of I, and I do I plus plus. It means less. If list dot size double equals to 0, then list dot add a of I plus plus, which is b of j plus plus. And okay, if it's the an array is not 0, then we go to else. Int prev equals to list dot get lost. We can do if last is not equals to a of I. Last is not equals to a of I, then only we do list dot add of a of I. We don't need to do I plus plus. Yeah. So by the end of the day, I'm doing I plus plus. Same goes to it. Else, and I was like, if last not equals to p of j, then I do list dot add of p of j. If it equals, by the end of the day, what am I doing? By the end of the day, I'm doing j plus plus. While I is less than a dot length, I'm doing these things again and again. While j is less than b dot length, I'm doing those things again and again. By the end of the day, I'm going to return the list. Here take an array list, right? So here also we need to take an array list. We need to instance the same instance. Let's compare and run this. It should work because I wrote everything right from scratch, clearly, neatly, efficiently. I used compile time error, which I accepted. What is last year? Which is this? 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 I know. List dot get off, list dot size -1. Okay. Instead of doing this, okay, it's only Java 1.2. Java 18. Let's replace all these things. And expected this should work, but let's rerun this again. If this should work now. 1, 2, 3, 4, 5, 1, 3. Oh man, what's happening here? Int I equals to 0, int j equals to 0. While I is less than a dot length and b is less than b dot length. If array of I is less than b of I, if list dot size double equals to 0, then list dot add a of I. Else we need to get the last element from the list. If the last element is not equals to current element, then we are adding it. If not, we are not adding it. We going forward. Just okay, well, if b of I is greater than or equals to a of I, then what we are going to do? If the list is empty, we are adding the b of j, which is wrong here because we don't need to do this. Which is wrong here. We don't need to do this. Now this should work now because we are here. Here we are doing j plus plus for so many times. Still it is wrong. What's wrong? Am I doing any extra stuff here? Okay, let's see. Okay, initially I taken I equals to 0 and j equals to 0. While I is less than a dot length and j is less than b dot length, which is right. If array of I, okay man, here it needs to be b of j. What is this? This should work now. Be careful. For b it is j, for a it is I. I. See it's j. Yeah, it works fine. Now let's submit this. This is union. We are adding two elements in the array and the order is same and this should work fine. Yeah, it got successfully accepted. Now let's go to a intersection of two arrays. Here we need to get the elements that which are equal in both the arrays but not repeated. How can we do this? I will take this one and I will search this. If it's okay, if I will take this one, yeah, the results must be unique. What am I going to do? Uh, what am I going to do here? Yeah, this take I will take this and this will get accepted. What is so here? In one watching. Okay, now let's start solving the section of two arrays. We need to get the numbers that which are common in the both the arrays, and we it may be unique. Okay, I was like I will take two assets, set of integer, set one for storing the elements in the number one, new asset. Now I am taking another set for integer, set 2 equals to new asset. Now I am storing in every number in nums1 in set 1. Yeah, now for every number in nums2, I am adding it to set 2. Now I am taking an array list. Okay, was like for every number in set 1, if set 2 dot contains that number, if set2 dot contains, if set2 dot contains, it return 2. If it doesn't contain, then we are set dot remove of number. Set dot remove of number. What? Set1 dot remove dot number. By the end of the day, we will have only the elements that which are common in the both arrays. So it is in set. I need to return it an array, right? So it is set dot size, and for not to return integer I equals to 0 for every number in set. Answer of I plus plus equals to number. This should work now. Return the answer. What is names and okay, it is number. Set dot size and set dot size. It's set one dot size. Can't find the symbol and it's set one. Yeah, I will debug the code and then I will get error. Now, okay, concurrent modification. We are iterating and we are modifying the how we can do this. So iterator of integer iterator equals to creating iterator for set. Haven't used iterator since last few months. I don't know. Set dot iterator removing, how to remove iterator dot remove. There was like, let's just copy this, paste this. Okay, copying is really a very bad thing, because so iterator that is in Java iterator it is integer. Why iterator dot as mesh value equals to if set 2 dot contains value, then iterator dot remove. It should work now. Safe way to iterator of integer iterator equals to set one dot iterator. Safe way right now. not contains kada. We are need to know what are the elements that which doesn't contain. Right, it's right. Let's ask start GPT whether this right. This it got accepted, but it beats X percentage. Now charge GPT will give correct. Optimal in train complexity, safe, uses iterator correctly. Use it clearly. Put all the elements in set one, iterate or etc. No element is not expected. Time and says complicit time and is what and it's right. It's right. Final and cleaned. Alternative one set plus check one. Okay. Int number equals to int number nums one. Number in nums if set dot contains number result dot add of number. Yeah, it's good, but yeah, it's good. It's good. It's 100% good and which is optimal also. So let's change the code. I was like result here. We are doing many. We are skipping many stuff right here. You know, we're skipping this code. If set one contains number, set one not contains number. What I'm going to do? I'm going to do result dot add of number. Hmm, Here we are going to do results result. Yeah, it got accepted. Let's submit this. Mm, Yeah, it got accepted and it beats 96.21 minutes, which is good as compared to before. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 problems has been solved inside 11, inside 1 hour, I guess. Let's see how much time. Yeah, inside 40 minutes. Yeah, it's a very good achievement, and that's all for